Hello everyone, welcome to Think Then Code. Today we'll be solving the problem rearranging fruits. We'll be looking at the intuition and observation behind the problem. We will be dry running the solution, understanding the code, and understanding the time and space complexity. So let's understand the question. What the question says is you are given two fruit basket containing n fruits each. These are zero index integer arrays basket 1 and basket 2. You want to make both baskets equal, and to do so you use the following operation any number of times. So what is the operation? You choose two indices I and j. I is of basket 1 and j is of basket 2, and you swap both the fruits in those baskets with index I and j, and the cost of this operation is minimum of basket 1 of I comma basket 2 of j. So two baskets are considered equal if sorting them according to the fruit cost makes them equal. Okay, makes them exactly the same basket. Return the minimum cost to make both basket equal or -1 if impossible. So looking at the sample test cases, basket 1 contains 4222 and basket 2 contains 1412. So if we transfer 1 2 from basket 1 to basket 2 and get 1 1 from basket 2 to basket 1, then after sorting both basket 1 and basket 2, they will be exactly the same. And the cost of this transaction will be minimum of 2 comma 1, that is 1. So that's what written in the sample test cases. Let's see the constraints. The length of the basket is 10 to the power 5. So we either have to do it in big O of n or n log n. So let's understand the observation behind this problem. One observation is very clear from the sample test cases that since in this sample test case the answer is -1. Why? Because if we see basket 1 and basket 2 here, the count of 4 in combined both basket is just 1. So we can either keep 4 in basket 1 or in basket 2. So to keep the elements of both basket same, all elements of the basket should have even frequency. That is, if there is 5, then there should be one more 5 here, or there should be 4 5s in combined both basket 1 and basket 2. So what I mean by this is every element which is occurring in any of the basket should have combined frequency as an even number, not an odd number, because we cannot distribute odd number equally between two baskets. Now moving forward, what is our operation? Our operation is basically the swap of two numbers. First is ith element of basket 1 and second is jth element of basket 2. Now this swap can also be termed as transfer. How? Basically what we are doing is we are transferring one element from basket 1 to basket 2, and we are transferring one element from basket 2 to basket 1. So I can reframe this operation as, let's assume this TS1, that is transfer of one element from basket 1 to basket 2, and TS2, where TS2 is the transfer of one element from basket 2 to basket 1. Now when we combine both of these transfers, this make a whole operation. And what is the cost of this operation? The cost of this operation will be minimum of E1 comma E2, where E1 is the element 1 which is transferred and E2 is the element 2 which is transferred. Why I explained it? It will be very much clear why I explained this analogy. Now let's assume we are giving this input where B1 is the basket 1 and B2 is the basket 2, and these are the elements. Now to make both B1 and B2 equal, we have to transfer some elements here. Some elements from basket 1 to basket 2 and some element from basket 2 to basket 1. Looking at the array, it is very much clear that there are two occurrences of 3 here. So we have to transfer 1 3 from here to basket 2. Also there are two occurrences of 4 and there are no 4 in the basket 2. So we have to transfer 1 4 also, and there are 4 9s in this array in basket 1. So we have to transfer 2 9s also in our basket 2. And when we look at the basket 2, there are 2 1s in our basket 2 and there are no 1s in basket 1. So we transfer 1 1, and in the similar way we will transfer this 1 2 7 and this 8. So when we transfer these numbers, they will make both basket 1 and basket 2 equal. So let's once write these number. Let T1 be the array which contains all number which are to be transferred from basket 1 to basket 2. So what this would be? It will be 3, 4, 9, 9. And let T2 be the list of all number to be transferred from basket 2 to basket 1. It will be 1, 2, 7 and 8. Now transfer of two numbers together make an operation. As we saw above, transfer of one number from basket 1 to basket 2 and transfer of another number from basket 2 to basket 1 make one operation. So what does it mean is we have to couple one element from T1 with any other element of T2, and that would make our one transaction complete. In this way, we have to do 4 transactions in this case to complete all the transfers and make B1 and B2 equal. So what is the cost of one transaction? The cost of one transaction is the minimum of the element that is being transferred. So let's assume we are transferring index wise, that is we are transferring 0 0 index, 1 1 index, third index and fourth index. So let's assume if we transfer like this, what will be the total cost? The total cost will be minimum of 3 1, that is 1, plus minimum of 2 4, that is 2, plus minimum of 9 7, that is 7, plus minimum of 8 and 9, that will be 8. So this will come out to be total 18. So what we are doing is we are coupling a smaller number with a smaller number and a larger number with a larger number. So if we are doing this way, actually the minimum of two large number is a large number. So we are actually wasting these two small numbers which can be utilized to get a smaller answer. How? What we can do is we can pick one smaller number from T1 and couple it with a larger number of T2. So if we do like this, let's see what the cost comes out. Smaller number of T1, that is 3, and larger number of T2, cost would be 3. Smaller number of T1, larger number of T2, the cost would be 4. Then larger number of T1 but a smaller number of T2, the cost of this transaction will be 2. And then a smaller number of T2 and a larger number of T1. So basically we utilized all our small number in the cost. This minimized the cost. So this will be 1 and the overall 4 3 7 and 7 plus 3, it will be 10. So we are getting our cost as 10, which is less than 18. So from this observation we can conclude that if T1 is the number of transfer elements which we have to transfer from basket 1 to basket 2 and T2 is the elements which we have to transfer from basket 2 to basket 1, what we can do is we can couple the smaller elements of T1 with the bigger elements of T2 to minimize the overall cost, and we can couple smaller elements of T2 with the bigger elements of T1. So in this way the cost can be minimized. So what we are doing is we are basically performing one transaction. So will be an element from basket 1 to basket 2, that is T1 transfer and T2 transfer. This is one transaction and the cost will be minimum of the element which are transferred. So we want to pass elements from one basket to other basket, and here we are doing it with one transaction. We are picking both elements. So we can also do the same thing with two transactions. And you might be thinking why we will do two transactions. I will show it now. Let's assume we want to transfer from T1. We will take one number X which can be in any basket and we will do this transfer. And also at the same X we will also transfer one element from T2. So if we are doing this two transaction, what is happening is there is only one transaction being performed on T1 and T2 elements, but there are two transactions which being performed on X. So if X was from basket 1, it will remain at basket 1, and if it was from basket 2, it will remain at basket 2. But the position of elements from T1 and T2 will get changed. Let's see what I am saying with an example. So let's say we want to transfer 4 to basket 2 and 7 to basket 1. So we are doing what we discussed earlier. We are transferring a smaller number from T1 and a bigger number from T2. So if we have to perform the transfer with just one transaction, what we would do, we would remove 4 from here and we would remove 7 from here. We would make this 7 as 4 and we would make this 4 as 7. So what would be the cost of this transaction? The cost of this transaction will be minimum of 4,7, which is 4. But what if we have to do it with two transactions? Now let's see that. Now let's assume I pick another number, let's say 1. So what I did doing with two transactions is, first I remove 1 from basket 2 and put a 4 here, and instead of 4 I put a 1 here. And now I remove this 1 and remove this 7. Instead of 7 I put a 1, and in place of 1 I put a 7. Now this both 4 and 7 are being transferred from buckets, and this 1 which was from bucket 2 remains in the same bucket. But what is the total cost? Basically we did two transactions. One transaction was to swap 4 and 1, which is having a cost of 1, plus another transaction which is having a cost of 1 and 7. Also 1 and 7 minimum is 1. So overall the cost came out to be 2, which is less than 4. So in this way also we can transfer elements from basket 1 to basket 2 and basket 2 to basket 1 using two transactions. But then you might be thinking, what is an optimal way to transfer these elements? So the optimal way is to get the minimum transaction cost. If you are getting minimum cost in just one transaction, add that to cost, or if you are getting minimum cost in two transactions, add that to cost. So if we want a minimum cost in two transactions, what X would be there? Like what number as an X you would like to pick to minimize this? So if we see what is the cost of a two transaction way of swapping the element, it is basically 2 into X, because this X, assuming it is lesser than T1 and T2, here the cost of this operation will be X and here it will be X. So the overall cost will be 2X, and we can pick this X as a smallest element in all the buckets. So if we pick this X as the smallest element in all the buckets, this 2X will be the smallest cost which we can incur. So one might also think that if two transactions can also give us a minimum answer in one transaction, so why not go above 2, like 3 transactions, 4 transactions. So let's assume we are considering 3 transactions. So we will have one element from T1, one element from T2. Let X be the smallest element and let there be another number, let's call it Y. So one transaction between T2 and Y, one transaction between T1 and X, and one will be between X and Y to keep them in the same bucket, right? So the cost here would be X. The cost between Y and T2, let's say Y, let's assume Y is smaller than T2, it would be Y. And if X is the smallest element, then the transaction between X and Y will result in a cost of X. So this will result in an overall cost of 2X plus Y, which is bigger than 2X. That's why we are not considering any transaction above 2 transaction systems. So let's summarize our solution. We are having two baskets B1 and B2. What we will do first is we will put all the elements from basket 1 which are to be transferred to basket 2 in a list or array known as T1. And in the same way, we will put all the elements which are to be transferred from basket 2 to basket 1, which are 1, 2, 7 and 8 in a list or array named as T2. Now we will sort both of these arrays to get them in an ascending order. Now what we would do, we would consider the smallest element of T1 and pair it up with the largest element of T2 to get the minimum cost. If we are applying a one transaction system, we will get the cost for one transaction system, let's call it C1, and we will get the cost for two transaction system. In this case, the minimum in all the baskets is 1. So we will consider 2 into 1, that is C2, will be equal to 2 into 1, that is 2. So we will get C1 as 3 and C2 as 2. So since two transaction system is costing less, we will add 2 to our answer. In the same way, we will move our pointers from 3, 8 here to 4 and 7. Again, we will make C1 as 4 and C2 will remain same because we are just applying transaction 2 times on the minimum element. Since C2 here is also less, we will add C2 to our answer. Now we will move our pointer to 9 and 2 here. Again, C2 will remain same, but the cost for one transaction will be 2 because minimum of 2 and 9 is 2. Since both are same, we add 2 to our final cost. Now we will move this pointer to 9 and the lower pointer to 1. The cost for one transaction here will be 1, that is minimum of 1 and 9, and the cost of two transaction will be 2. So we will add 1 to our answer, and that's how the final minimum cost will be made. I hope you got the approach. If you did, please like and subscribe. Now let's look at the code. So this is the accepted code. Let's have a look at it. First, I have created an unordered map for storing the combined frequency of both of the basket, that is basket 1, basket 2 combined frequency. So here I am just calculating combined frequency, and in this loop I am traversing the map and checking if any element of the basket is having odd frequency or not. So if any element of the basket is odd frequency, we cannot distribute that equally, we directly return -1. So once we are done calculating combined count, what we do is we create our arrays T1 and T2. That is, T1 represents the element which have to be transferred from basket 1 to basket 2, and T2 represents element which has to be transferred from basket 2 to basket 1. So how we will calculate this? Let's have a look on this function get transfer. So this function get transfer takes a basket and a combined count. So what we are doing first is we are filling current count, that is the current frequency, and this transaction is the array which will return as our answer. So we fill the current frequency and we traverse combined count. So while we are traversing combined count, we check if the count of a number in our basket is greater than the combined count of that number by 2. So what this basically means is, let's assume we are having 9 and the combined count of 9 in both of the bucket is 4. So this means that both of the baskets should actually have only two count of 9. And if the current count of 9 in basket 1 is 4, it means that we have to transfer 2 9s from basket 1 to basket 2. So that's the same code I have done here. We check if the current count of the number is greater than combined count of the number by 2. We get the current count and we increment the current count until the current count doesn't become combined count by 2. And in the meantime, we also push back this number in our answer, that is transaction, and finally we return this transaction. That's how this transaction array is being filled. And in the same way, it can also filled by T2. So once both T1 and T2 are filled, we sort both as we discussed in our solution. We get minimum element from both of the baskets, and then we traverse T1 from the beginning, that is smaller number from T1, and we traverse T2 from the end. So this I pointer is for T1 and this J pointer is for T2. So we put this condition that I pointer should not go ahead of the size of T1 and J pointer should not be less than 0. And this is the operation in which we are getting the minimum cost. This is basically the cost for one transaction system, that is minimum of T1 of I, comma T2 of J, and T1 of J, and T2 of T2 of J. And this is the cost for one transaction system, that is minimum of T1 of I, comma T2 of J, And this 2 into minimum element is the cost for if we are doing 2 transactions through a minimum element. So whatever be the minimum cost, we add it in our answer and we finally return our answer. So let's have a look at the time and space complexity of our approach. What we are doing is we are creating an unordered map, which is a constant time lookup. We are filling it, which is all linear. This get transfer function also works in a linear time complexity. Only the costly operation we are doing is sorting, that works in a n log n time complexity. Every other thing is just a linear time complexity. So overall time complexity of our approach is n log n. Talking about space complexity, we are creating two vector t1 and t2 and also storing combined count. So overall space complexity of our approach will be big O of n. I hope you got the code. If you have any doubts about the approach or the code, please comment them in the comment section. I will try to respond to your query. So that's all from my side. Hope to see you in the next video.